afternoon and welcome back. In this topic, we look at network services and applications. Network services and applications. All these services we're going to look at are very important because as junior network engineers, you'll have to configure them in your networks. The internet has become an integral part of our lives with a wide range of applications such as file transfer. So there's a protocol that enables that. Email sending, there's a protocol that enables that. And when you see these services, please just know that it means you might have a server. You might have a server in your network for file transfer, for email sending and receiving, for online video, for your website, a web server, email server, online gaming, etc. Because of the layered network model, common users can use various services provided by the application layer without knowing technical details such as communication technology implementation. So really, your users will never know what goes on behind the scenes, but they'll want to access the email from within the organization and also from without. For example, in the previous courses, we have learned technologies related to the data link layer, network layer, and transport layer. This chapter will describe common network services and applications such as FTP, DHCP, and HTTP. By the end of this chapter, you will have an understanding of the following application layer protocols: FTP, TFTP, DHCP, Telnet, HTTP, DNS, and NTP, Network Time Protocol. They're interesting stuff. So let's begin with file transfer. FTP and TFTP, they're used for file transfer, downloading and sharing files. Okay. So file transfer protocols, they enable the file transfer between hosts. As you can see here, like these two, they're exchanging documents, movies, etc. So that is the protocols that do that. However, in the early internet of the World Wide Web, it did not come into being, and operating systems used command line interfaces. So people transferred files via command line tools. So before we had user graphical interface, for doing that, we used to use command line tools. The most commonly used protocols for transferring files include the File Transfer Protocol, FTP, and the Trivial File Transfer Protocol, TFTP. So let's look into these two protocols. So we begin by FTP. Now, FTP, just like TFTP, adopts the client-server architecture. Client-server means we will have one device acting as the client and one device acting as the server. So in your network, you'll have an FTP server that stores common or shared organizational files that might need to be downloaded by different people in your network. So people can be able to log into that server and download it. A typical application scenario, for example, at MMU, we have a file server that hosts the common applications that our staff need. So that when I need to go to a particular computer and I want to install, for example, an email system called Groupwise, I simply log into the file FTP server, then I download the .exe file, then I install, then maybe I delete that particular file from the FTP client. Are you getting the point? Are you getting the point? Yeah, so that the network administrators don't need to carry files on either hard drives or flash drives or disks. You just set up a server that will host all the files, the antivirus, blah, blah, blah. So when you go to any office, you just connect to the network, log into the FTP server, and download the file. Okay, now FTP uses different transfer modes based on the file type. So it uses two. One of them is called the ASCII mode, and the other one is called the binary mode. ASCII, I don't remember what it means in full, but it's the American standard for something called something interchange, ASCII. Now, for the ASCII mode, it is used to transfer text files, log files, configuration files, etc. So normally, files that are in form of text, they have to be converted. They have to be converted into ASCII mode before they are sent over the network. Whether we are uploading or downloading, we have to convert these text files. So please remember that. On the other hand, we have other files that are non-text files. And for example, the .exe files, movies, images, etc. So for those kind of files, we normally transfer them using the binary mode. We use the binary mode because we do not need to convert these files before sending. Are you getting the difference between ASCII and binary? And the kind of files that we can transfer using either of those two modes? Yeah. Okay. So it is important that you know that, because if you want to download or upload a configuration file, you need to know that you're going to use, you need to understand that you're going to use, for example, the ASCII mode to do that. Okay. Now, a FTP transfer process can be what we call active mode or passive mode. Active mode or passive mode. So let's try and understand the difference between these two. Okay. FTP uses TCP. Particularly, it uses port 20 and port 21. Port 20 and port 21. Now, port 21 is used for what we call control. Control what? Control connection. Control connection, port 21. Then it uses port 20 for data transfer. It uses port TCP port number 20 for data transfer. So don't forget that. Where can I put this? Okay. So as we said, FTP uses TCP. So before an FTP client and FTP server begin to communicate, they have to go through the TCP three-way handshake. So the server will be listening for the control connection. What control connection means is when we are doing the three-way handshake in order to form up a TCP connection. So that's what we call control connection. So that connection is set up via FTP port, TCP port number 21. So we do the three-way handshake. Then after doing the handshake, we do the authentication. So we have to prove that you're who you claim to be through maybe a password and a username. Then the FTP client will send a port command. So look, when you're using active mode, we use the port. When you're using the passive mode, we use the pass command. So the FTP client will send the port command to the FTP server, instructing it to open port P, which is a random port that has to be greater than 1024. So I told you about the random ports. In the previous chapter, I told you about the TCP random ports. They're normally greater than 1024. Okay, so after telling it to open that, then what happens next? The FTP server, port 20, you see, the FTP server, port 20, initiates a TCP three-way handshake with TCP port P, this one that it opened, on the FTP client to set up a connection. So after doing that connection via port 20, now they can be able to exchange the files. The client can be able to either upload or download files from the server. Is that clear? Wonderful. Okay. So the next mode is the passive mode. Passive mode. Now, with passive mode, again, it begins by doing a TCP three-way handshake via TCP port number 21, then authentication. But this time, the FTP client sends the pass command. The FTP server then enters the pass command to the FTP client, instructing it to open port N. So the client now is going to open port N. Then the client will initiate a three-way handshake with TCP port N on the FTP server to set up a connection. Then after that, they're going to exchange. They're going to exchange data. Now, in the notes, they explain further on the main difference between the active and passive command. I'll leave that to you as a reading assignment. Please make sure you check it so that you understand it better. Okay, now, how do we configure a device as an FTP server? Now, what I need to mention is that many network devices can act as both FTP clients or FTP servers. So like routers, firewalls, switches, they can act as this. So in order to configure one of those devices as a server, for example,
FTP. Okay.
Can you still? Uh-oh. Can you hear me, Maurice?
Yes, teacher.
Yeah, right now I can hear you.
Okay, sorry. Okay, so we're looking at how to configure an FTP server. I've just mentioned that most network devices like firewalls, routers, and switches can work as both FTP clients or FTP servers. So to configure a router, for example, to be an FTP server, the command you use is FTP server enable. FTP server enable. By default, FTP server function is disabled. You have to do that on system view. So the command is FTP server enable. Then how to configure a local user to access the FTP server. You go into AAA, you create the user like we normally do. Then you create the privilege level. You give them a privilege level. Then after that, you enable the service type, the FTP service type. So that's the most important thing. The other important thing with FTP is that you must give them a default directory, FTP directory, so that when they FTP to that machine, to which directory are they going to land in by default? So you must set this using that command, local user username, FTP-directory. Then you, for example, say flash. Now, it is important that you understand that FTP cannot work unless the privilege level of the user is 3 or higher. It has to be 3 and above. So here, when you're giving the local user a privilege, give them a privilege of 3 and above. Otherwise, they cannot be able to log in using FTP. Okay, let's look at the client side. To FTP into a server is quite easy from a client. It's just like Telnet. We've seen Telnet several times. You just write FTP, then the IP address of the FTP server. After that, it's going to ask you for a username and a password. So you're going to enter the username and password, and then it's going to tell you you're in. Okay, common commands that are used when the VRP device function as an FTP client. So for example, you can use the ASCII command to specify that you want to convert before downloading using ASCII, or you can use binary if you're downloading the executable files or the VRP.
I think there's an application that is affecting my mic. You can use ls to list the
terms of a particular. Okay.
Please give me a minute. I sort this out. Okay, so ls is a command that is used to list the contents of a directory. Passive, to set the toggle passive mode. If you want to, normally it's on, if you want to turn it off. Then get is used to download a file, while put is used to upload a file. So we are going to see that just now. So let's configure this router here as the client, and then this one as the server. Then we can use the get command to download a file from the server. So how then do we do that? So for the server, we have to use the command FTP server enable. FTP server enable. Then we go into AAA. We create admin 1234 and the password. Then the privilege level, we give them 15. It has to be 3 or higher. Then we enable the service type as FTP. So local user admin 1234 service type FTP. Then after that, we configure the default directory. So FTP directory flash full colon. So this will take them to the flash directory. Okay, so on the client end, we will go into the client, then use the command FTP, then the IP address of the FTP server. Normally it's the IP address of this particular interface there. Then after that, we can use the get command. Get, then the name of the file we want to download and the extension. So get the name of the file and the extension. So after we do that, when it's done, it's going to give us the report as it downloads the file.
Okay.
So that's it about FTP. Any question? Any question on FTP? Question or comment?
Okay, so let's now look at the basics of TFTP. Trivial file transfer protocol. Main difference with FTP is that instead of using TCP, it uses UDP. So as you know, UDP does not require a connection. UDP is connectionless oriented. So you don't need to form a connection. So you can just start downloading or uploading without forming a connection. So you just start sending. So that's the main difference between FTP and TFTP. Also, in TFTP, authentication is not required. Please don't forget that. Authentication is not required. While in FTP, you must be authenticated. You can only request a file from or upload a file to a server, but you cannot use the ls command to view the file directory on the server. So the disadvantage there, you cannot be able to view. Okay. So what happens when you are uploading a file? You request for writing a file. Request for writing a file. Then you'll get a file write confirmation. File write confirmation. Then after that, you can start writing. So you can send data 1, then you'll get an acknowledgement for data 1, and so on and so forth. So that is the upload process. Download, you will request to read. So instead of writing, now you're requesting to read. Then you'll get a confirmation to read. Then you'll confirm that I can start reading. Then you can now start reading as you also acknowledge whatever you receive. So that's how it goes. Generally TFTP uses 5 packets. To achieve this, the first packet is called RRQ, second one is called, the third one is called data, the fourth one is called ACK, and the last one is error. So RRQ is read request. Read request. So when you're sending a request for reading a file, you send an RRQ packet. When you're sending a request to write a file when you're uploading, then you send a WRQ or write request packets. Data is the packet for data transmission. ACK is acknowledgement. You acknowledge the receipt of data from your peer. Error is error control packets. How to configure TFTP client? So you use the keyword TFTP, command TFTP, then the IP address of the TFTP server, then get the
I said you don't need
to log the server. You only enter the IP address of the TFTP server.
Yes.
Okay.
Is on actually affecting my audio. Okay, so how to configure? Hey, how to configure? How to configure TFTP client? TFTP, then the IP address of the TFTP server, and then get, then the name of the file, location and name of the file you want to download. Otherwise, if you want to upload TFTP, IP address of the server, then keyword put, and the location where you want to, location and name where you want to upload that particular file. Now, it is important to note that IP devices VRP devices can only function as TFTP clients. So you cannot configure them as TFTP servers. So that's why here we are only giving an example configuring the client. This mic is still misbehaving. Okay, so I just disconnected that. Can you still hear me, Maurice?
Yeah, we can hear you. I can hear you, teacher, from my side.
I'm sorry. Okay, let's continue. So let's look at Telnet. Telnet, another very important protocol, Telnet. So again, you'll be using Telnet. You'll be using Telnet for device management, using commands all the time in your network. So Telnet enables you to configure devices over the network other than configuring your devices physically by connecting them physically to a console cable via a console port. Now Telnet adapts the client server architecture too. So you have a client and you have a server and you have the Telnet server. Now all these network equipment like an access point, a router, a firewall, a switch, a server can be configured as Telnet server. Telnet uses TCP port number 23. Expect this kind of questions in the exam. For port number, we said FTP uses port 20 and
21.
24.
24 mails and 80 something else.
80 is for HTTP. But 20 is for data transfer, right?
Yeah.
21 is for control connection. Okay, so Telnet port 23. Now the device that can be managed through Telnet, hey, look here. The device that can be managed through Telnet is called the Telnet server. So if you want to be able to configure your devices, your router via Telnet, you have to configure it as a Telnet server. That is what that means. Device connecting to the Telnet server is called the Telnet client. For example, your network management system, the machine you're using is the client. But the devices you're managing over the network is the server. Okay. All these devices can act both as a Telnet server and a Telnet client. Now, there's the concept of the VTY, virtual teletype interface, user interface. Now, this user interface is what you get when you access your device via Telnet. Now, when you log into your device using a console port, you only have one single user interface, and only one person can log into that device and configure it at a time. But when you log into your device using Telnet, you have what we call the VTY user interface. The VTY user interface can provide several user interfaces from VTY 0, 1, 2, 3, and so on and so forth. So by default, you can be able to create 0 to 5, 0 to 4, but you can be able to extend this to 15. Meaning that if it's 0 to 4, only 1, 2, 3, 4 people can be able to do it. To Telnet into the device at any given time. So that is what happened. So normally the process is like this. When the client sends the request, they establish what you call a telnet location. Then your telnet server will allocate an idle user interface with the smallest number from the VTY user interfaces. Then after that, authenticate the telnet connection using the VTY configuration. So after that, the last bit now is authentication. Authentication. So please remember the virtual type terminal, VTY, user interface, that is used as the user interface for telnetting. So how to configure a telnet server? Use the command telnet server enable. Telnet server enable, by default, it is disabled. If you want to disable, you use undo. Undo. Okay. To enter the VTY user interface view, or to create them, you use the command user-interface space VTY, then the first user interface number, for example 0, the last one, for example 4, like that. After that, you need to configure the protocols that is supported by that VTY interface. VTY interface can support telnet or SSH. So you use the command protocol inbound, then telnet, SSH, or all in order to support both of them. SSH is secure shell. Secure shell. Unlike telnet, this one encrypts. It's more secure than telnet because it encrypts data as the data is being exchanged between your device and between your network management system and your network device that you're configuring. So for example, when you're configuring passwords and so on and so forth, they'll not be sent over the network as plain text. So SSH is the secure version of telnet, really. Okay, so after that, you need to configure the authentication mode. So you choose authentication mode. Most of the time, you're going to be using AAA, of course. Then you can set a password. This command for setting password, it's different on different devices depending on the VRP version. I hope we saw that during the lab. Okay, so this is a configuration example of telnet. In this particular case, we want to create, we want this guy to act as the telnet client. We want the router to act as the server. So we need to create an account named Huawei with a password Huawei at 123, set privilege level to 15. Then log in to manage the telnet server through the telnet client. So how to do that? On the telnet server, we get into the system view, we enable the telnet server using the command telnet server enable. Then we go into AAA to create the user Huawei and the password, that one. Then we configure the privilege level for the user Huawei. Then we enable Huawei to use telnet using the service type command. Then after that, we can create the VTY interfaces 0 to 4. Then we choose the authentication mode as AAA. So once we've chosen that authentication mode, we don't need to set the password because when we created the user, we defined the password. So after that, on the client, we can telnet into this device. How to do that? On the client, on the host, you just write on CMD telnet, then the IP address of the device you want to telnet to. If you enter the correct username and password, you are going to get the prompt. The prompt of that particular router, just as if you logged into that router using using what? Using a console cable. Are we together? Yeah, and from there on, you can be able to configure that device. So you're going to do this in the lab. Okay, so let's now look at DHCP, Dynamic Host Configuration Protocol. Now, dynamic host configuration protocol is a protocol that is used to automatically assign IP addresses. Automatically assign IP addresses to hosts in your network. Now, traditionally, this used to be done manually, but manual work has several disadvantages. One of them, on your host, you need to configure quite a number of parameters. These parameters are quite hard to understand. I remember when I joined MMU in 2010, we used to manually configure IP addresses. And other students had a lot of trouble, non-IT students, because they couldn't understand all these things. So you had to configure an IP address, you had to configure a mask, you had to configure a gateway. So we also have other parameters sometimes that you need to give. So all those parameters, they might be difficult for your end users to know how to configure them. And number two, it's also a lot of workload to your network administrators if they're the ones that are supposed to do that. Of course, as we know, it's also repetitive task, which is boring, and it's prone to errors, misconfiguration, prone to errors, and might cause IP address conflicts in your network. So those are the problems. Those are the problems with manual IP configuration. The other problem with manual is low utilization, because once you are assigned a private IP address, then you have it. It is yours forever. So when you're not logged in, when you've shut down your machine, and then no one else can be able to use that IP address. So on an enterprise network, each user uses a fixed IP address. So as a result, the IP address utilization is low, and some IP address may remain unused for a long time. The other problem is poor flexibility. For example, in a wireless local area network, you want students to be able to move from one class to another and still be able to connect to your network and maybe the internet. So if you're using manual IP addresses, then it becomes hard for you to configure your wireline devices or access points to be able to support those stations. So DHCP solves all these problems, So how does it work? Easy. You connect to the network, then you request an IP address. Then the DHCP server will assign you an IP address. It will send you an IP address together with other configuration details like the gateway, the DNS server, etc. So DHCP, just like the other protocols we've looked at, adopts the client-server architecture. So whoever is requesting the IP address, the hosts are the clients, but you'll have a workstation in your network that you'll configure as a DHCP server, so that it can assign IP addresses to your clients. So DHCP enables what we call plug and play. So people just come to your network, they connect, and they don't have to configure anything. They can start using your network or access the internet via your network. In your cut, did you have a question about? Did you have a question about this? Did you find any question about this? Huh? I'm not sure. Have we talked about this at any point? Have we talked about gratuitous ARP at any point? In any topic, when we were talking about ARP, did we talk about this? Yeah, we must have talked about this. We must have talked about it. We must have talked about it. Anyway, let me just repeat. What gratuitous ARP is this. If we are doing manual configuration, listen, if we are doing manual configuration of IP addresses, so we configure this guy with an IP address 192.168.1.2. Now, before this guy starts using that IP address, it's going to send out a gratuitous ARP. A gratuitous ARP is just like any other ARP, only that its specific purpose is to find out if anyone else is using that IP address on the network. So we've configured 192.168.1.2. This guy is going to send out a broadcast ARP packet asking, hey, who has 192.168.1.2? So if someone replies, then this guy will know, you can't use that IP address. Are you getting the point? If no one replies, then it can continue using that IP address. So that's how your operating system is, or your machine is able to tell you that, hey, you can't use this IP address, it's being used by someone else, if you try to do manual configuration. So that is what gratuitous ARP does. It's used to ensure that we don't have IP address conflicts when you're doing manual configuration. Advantages of DHCP: unified management. So really, the network engineer just has to configure every parameter here. So create a pool of IP addresses that you want to give, specify the IP address of the DNS server, the IP address of the gateway, and the DHCP server will issue them out. These clients will simply request, and the DHCP server will issue them out and keep a list or record of how many have been used and how many are free, for example. Also, we can be able to reuse IP addresses and therefore make better utilization of IP addresses, because when we assign an IP address, we assign it for a particular limited amount of time. It's called the lease. It's called lease. So we lease it, for example, for 8 hours. So after 8 hours, you have to release that IP address so that someone else can use it. Okay. So the working principle of DHCP. Okay. So normally, with DHCP, we normally remember the working mechanism using the acronym DORA. DORA is discover, then offer, then request, then acknowledge. So let's understand the DORA process. So first, when you connect your device to the network, it's going to send a DHCP request, a discover packet, right? Not request, discover. The discover packet is used to discover DHCP servers on the network. Normally, this packet is broadcast. Broadcast means the destination address is 255.255.255.255. So everyone is going to receive it. Everyone is going to receive it. Now, if a DHCP server exists in your network, it's going to reply it's going to reply with an offer, DHCP offer. The DHCP offer is a unicast message. It's unicast because when you send the discover, we get your address from the source address. So we are going to offer you an IP address and other details from a pool. Now, after we've offered you an IP address, you have to request for it. So again, the request, just like the discover, is a broadcast. So the broadcast at the request is used to inform the server that it will use this IP address, but not just this server. Please listen to this keenly. Look up, listen to this keenly. Typically, in actual implementation in your network, for redundancy and backup, you might have more than one DHCP server. Are we together? More than one. So when the discover is sent, several of them might reply with an offer. Are we together? So the request is broadcast so that all the other servers can be informed that, hey, I'm not going to use yours. The one I'm going to use is this one. Is that clear? Please don't forget that. Expect a question about this in the exam. For example, they'll tell you the DHCP offer message is a broadcast message. So that's how they'll ask that question. Then you choose between true or false. Okay, so after doing the request, which is broadcast, then the server which assigned that IP address is going to reply with an acknowledgement. So the acknowledgement is a what? A unicast. Yeah, sent to only that client. Okay, so I hope that is clear. DORA, don't forget DORA. Okay, so there's the concept of also of lease renewal. As we said, DHCP offers IP addresses for a limited time. That limited time is called a lease. By default, Huawei devices leases they lease IP address for 24 hours, for 1 day, 24 hours. That's the default. Now, lease renewal is, I have this IP address, the lease is almost expiring, but I still want to use it. So how is that done by your machine? What happens is this: at 50% of the lease, so if it's 24 hours, then at 12 hours, we are going to send a DHCP request packet, which is unicast. So we are going to send a unicast DHCP request packet. The purpose, to request the server for an IP address lease renewal. So if the server gets it, it's going to reply. It's going to reply here. It's going to reply with a DHCP acknowledgement. So DHCP acknowledgement here is to notify the client that the IP address can be renewed and the lease is updated. So for example, if the lease before was 8 hours and at 4 hours you ask for renewal, then it's going to be updated back to 8 hours. Is that clear? Now, in case you send this request, but the server here is down. So if the client waits until 87.5% of the lease, that time is known as T2. Sorry, 50% of the lease is known as T1. 87.5% of the lease is known as T2. If it reaches T2 and it has not received an acknowledgement, an acknowledgement, it enters what we call the rebinding state and broadcasts a DHCP request packet so that it can now request a new IP address from any other DHCP server that is on the network. Are you getting the point? Is that clear? Wonderful. Okay, so how do we configure a device as a DHCP server? DHCP enable. Then on an interface, DHCP select interface. So we can configure either on an interface or we can configure globally. So after that, we can use the command DHCP server DNS list. Then we give an IP address. So this is used to give the IP address of a DNS server. So I'm going to tell you what a DNS server is just now. So be patient. But just know that's one of the IP address that hosts need in order to access the internet. Okay, the other thing we're going to do is to exclude some IP address. Using the command DHCP server exclude IP address, then we give it some IP address. Normally, we want to exclude IP addresses such as the IP address of the DNS server, the IP address of the gateway, so that these IP addresses cannot be assigned to hosts because we've already assigned them permanently to our servers, like DNS server or web server, and so on and so forth. Is that clear? So that's the command, DHCP server excluded IP address. Okay, yes, Maurice?
Yes, teacher, sorry for interruption. Just wanted to confirm, is there a command that actually allows you to stop the server from actually assigning IPs, a certain range of IPs, that is, not manually configuring one to, let's say if you've got 100 IPs, you don't want them to be assigned. Is there a command that can actually allow you to group them into one and then you just upload them?
Oh, sorry, I think my internet connection is a little bit unstable, so I was losing you at some point. Can you kindly come up again?
Yeah, I just wanted to know if there is a command that can allow you to have that command for a certain range of IPs not to be assigned. A certain range of IPs, meaning if you've got, let's say 100, other than you typing in IP number 1 all the way to 100, you can just group them and say IP range from this to this.
Okay, so this is how you do it. I was just assuming because I think we've done this before in the lab. But as you can see from here, you can put the start IP address and the end. So for example, we don't want to give 192.168.1.240, for example, to 192.168.1.254. So maybe we want this lot. We want to use them for our servers and the gateway. So that's how you give the range. So all the way from 240 to 254 is not going to be assigned to end devices. Is that what you're asking?
Yeah, that's what I was asking. I think I had missed that.
Okay, wonderful. Thank you. Okay. Oh, so here. This is how you configure the list day if you want to change from the default DHCP server list, then the keyword day, then the number of days. The keyword hour, then number of hours. The keyword minute, then number of minutes. Or if you want to assign IP addresses permanently, you can use the unlimited option. DHCP server list unlimited. Otherwise, as I said earlier, by default, IP address list is 1 day. So you're going to do that in the lab. Okay, so you can also configure DHCP on the global rather than on the interface. So how to do that? You do IP pool, then the pool name. This is just a name. For example, pool 1. Then you get into that pool. For example, here we're in pool 2. Then use the network command. Network, IP address, then the mask. So for example, network 192.168.1.0 space 24. So you can use either the mask or the mask length. Okay, then after that, you need to configure the gateway address. To do that, you use the command gateway list and the IP address of the gateway. DNS list, IP address of the DNS server. Okay, and then list, then you give it the list. Then you now need to enable the DHCP server to function on the interface. To do that, you go to the interface and use the command DHCP select global. DHCP select global. So again, in the lab, you're going to do these configurations. So this is an example. We want to configure this router as a DHCP server. So this time we want to use the interface address pool, the interface. So we're going to configure this interface to issue IP addresses. So we're going to first enable DHCP using the DHCP enable command. Then we go into that interface. We use the command DHCP select interface. We specify the IP address of the DNS server. We exclude the IP address of the DNS server so that it cannot be issued, and we change the list day from 1 to 3 using that command. So that's how we do that. Otherwise, other than configuring the DHCP on the interface, we can also do the global address pool. To do that, again, you start by enabling, then you create a pool, for example, pool 2. Then you give the IP addresses that you want to assign to the end devices. So you want to assign IP addresses from this network range. Then the IP address of the gateway, the IP address of the DNS using that command. List day, you change to 10. Then you get into that interface and you use the command DHCP select global. DHCP select global. Okay, so that is it about DHCP. Anyone with a question? Anyone with a question? Configuration protocol. So that is DHCP in full. DHCP. Okay. HTTP, as we wind up. Now, HTTP is the protocol that is used to transfer web pages over the internet. HTTP in full is Hypertext Transfer Protocol, an application layer protocol for communication between client browser and a web server. So again, HTTP adopts a client server architecture. So we have web pages that are hosted on a web server. Then you in your computer, you can be able to enter what we call a URL, a uniform resource locator. So the address you enter, for example, www.huawei.com is called a URL. So when you enter the URL and press enter, your device, which is now the client, is going to send a HTTP request to obtain that particular resource, that particular page. And once the server receives it, it's going to check, are you authorized to access that resource? If yes, you are going to receive that particular resource in a HTTP response. So we have HTTP request in blue there and HTTP response. HTTP uses what? It uses which TCP port? Port number 80. So the background of HTTP or the internet. So in the early days of the internet, the World Wide Web was used to share documents. It was used to share documents. We have a beautiful story about that on the internet. You can Google and watch it. But the project was between universities and the American Defense Forces in a project called the ARPANET. ARPANET, Advanced Research something. So it was simply used to share files or documents between the university and the research departments of the military. Now the WWW or World Wide Web consists of three parts. The first part is the HTML. The HTML or hypertext markup language is used for displaying the document content in a browser. The second part is what we call HTTP. HTTP is used to transmit documents on the network. Then we have the last part, which is URL, that is used to specify the document location. The document location on the network. The document location on the network. So for example, mmu.ac.ke, CIT, maybe lecturers or courses. So that is what we call a URL. A URL has the domain name. This is the domain name. The domain name, it has the protocol bit, and it has the location of the resource you want. The location of the resource you want on that particular server. So the domain name is actually the name of the server that you want to access. And it's normally translated into a public IP address by the domain name server, which you're going to look at just now. Okay. What else is here? www was actually the name of the client application for browsing HTML documents and now represents these three technologies and is commonly known as the what? As the web. Yeah, it is important that you understand how the web works, because really in managing your devices, sometime you'll be managing them by using the web, right? The web portal, rather than via telnet or via console. Okay. What is this? Transfer. Okay, so this is just a transfer example. So the example here simply shows that you've entered a certain URL in your browser. So when you enter that URL, the request is sent and it uses the get this resource, web /index.html. We are using HTTP 1.0. The host server is www.servsapp.com. So that's going to go like that to the internet. The request is going to be sent until it gets to that server. Then when the server receives the request, first of all, it actually authenticates. Are you allowed to access that request? If yes, it's going to look at the file system and find that particular resource. So it's going to go to the web folder and find this page. So under the web folder, we have a page called index.html. So the server will find the locally stored page file based on the URL and send the page to the client. I'm going to send it to the client. When it is successful, the search, it normally returns this value, but I won't explain it here. And with an OK and the file itself, then your browser will display that HTML page, index.html. So that's how the web and HTTP generally works. Okay, so now let's look at DNS. Very fast, I've been promising you that we're going to look at DNS. This is the time to look at the domain name system server. Domain name system. Now, when you enter a domain name in your browser to access a website, the domain name is resolved to an IP address. The browser actually communicates with this IP address. So look here. When you type Huawei.com, we have domain name resolution, which translates this to a public IP address. So that server that stores this mapping between a name and a public IP address is what we call the DNS server. The DNS server. So normally, reason as to why this was done is because people don't remember numbers easily, but they remember names better. So you might not remember 1.2.3.4, but you might remember easier Huawei.com. So initially, we just used to access servers by typing their IP addresses. But that was quickly overtaken by the use of domain names. And now, in order to translate domain names to IP addresses, then we needed the domain name server. Okay. So DNS is proposed to map IP addresses to alphanumeric character strings. Alphanumeric character strings. Those alphanumeric character strings are what we are calling domain names. So Huawei.com, www.huawei.com, that's a domain name. That's what we call a domain name. Okay, so DNS components, number one is domain name, which I've already explained, and the next one is the server. The server maintains mappings between domain names and IP addresses, and it responds to requests from the DNS resolvers. So again, DNS adapts a client-server architecture. So we have the client, who is you with your mobile phone wanting to visit Huawei.com. So when you type Huawei.com, your machine is going to send a DNS query with Huawei.com using UDP. It's going to find the DNS server. It's going to send to DNS server because you remember the DHCP server issued the IP address of the DNS server. You remember that? So you are configuring DNS list, then an IP address of the DNS server. So you understand now why that was important? And I'm liking this note because this was not there in the previous notes. We were not teaching about DNS, about HTTP, about NTP. So at least now we're able to mention that. Okay, so the server will receive the request, then send the IP address. Send the IP address that is associated with that domain. Send it back to the client. And now the browser will be communicating with that IP address. For you, you'll be seeing Huawei.com, but at the back, it's simply communicating with the IP address and not the name. Is that clear? The domain name format is, as you can see, it adapts an inverted tree like structure or architecture. So at the very top of it, we have what we call the root domain. The root domain is normally depicted by the dot. After the root domain, then we have the top level domain. The top level domain are global domains like .com, .net, .edu for education, .org for organizations, .gov for governments. So that's what we call TLD, the top level domain. Then you have second level domain like Huawei. Then we have host name like www. So www.huawei.com. So mmu.ac.ke. Okay, so DNS query modes, we have two modes, the recursive query and the iterative query. So we want to understand the difference between the two. Now, DNS is a distributed system. Distributed system. The database of most DNS servers does not have all domain name records. It does not have all domain name records. So when a client queries a domain name from a DNS server, but the DNS server does not have the record, of the domain name, the client can continue the query in either of the following ways. So by distributed it means at MMU we have a DNS server. The DNS server is on, for example, 192.168.1.251. That's the IP address of the DNS server. So this is MMU. But on the internet, we have 8.8.8, which is Google DNS server. We have 4.4.4, which is also a Google DNS server. And we have many other DNS servers. Some have public IP addresses and therefore can be reached publicly, some are local. So what it means is this: depending on the websites that our students have accessed, our DNS server here will only have mapping between those domain names and IP addresses. So in case a new student comes and enters a domain name whose IP address or mapping the MMU DNS server does not have, it's going to send a request, for example, to the Google DNS server to see if the Google DNS server has that mapping. Are you getting the point? Is that clear? If the Google DNS at 8.8.8 does not have it, it's going to send maybe to 4.4.4 to see if this one has it. So that's what we call distributed. So you might not have everything, but you can always check with others and find it. So you can check in one of two ways. The first way you can check is what we call recursive query. In recursive query, the client, which is your machine, will send a DNS query to the DNS server. Hey, what is the IP address of Huawei.com? Now, unfortunately, the MMU DNS server does not have the IP address of Huawei.com. So the MMU DNS server has been configured to send a request to the Google server for any domain name whose IP address it does not have. So it's going to send to the Google server. Then the Google server is going to reply, hey, you can find Huawei.com on 2.3.4.5. Then finally, the MMU DNS server is going to respond to the client and tell the client, hey, you can find Huawei.com on 2.3.4.5. So that's recursive. Let's see iterative. How different is iterative? Iterative is like this. Iterative is like this. Which example can I give? I'm trying to find an analogy. With iterative, you ask your friend. So this is your friend, DNS server 1. You ask your friend, hey, where did you buy that nice shoe that I saw you with? Then this guy tells you, I bought it at Tuskys Pioneer. Then you go to Tuskys Pioneer and buy the shoe. Is that clear? Otherwise, we have some very mean friends. They're very mean with information. That is what recursive almost looks like. Hey, where did you buy those nice shoes? And this guy will tell you, leta pesa nikununulie. I can't tell you my source, give me money. Give me money, I'll buy it for you. So they'll go and buy it for you, take it, and deliver it to you. So that's recursive. Iterative, you just tell, hey, check with the Google server. Hey, where is Huawei? Where is Huawei? What's the IP address of Huawei.com? If they says, I don't have it, please check with the Google server. And this guy then goes to Google server. Hey, what's the IP address of Huawei.com? Google server has it, so it returns 2.3.4.5, like that. So we got the difference between recursive query and iterative query. Wonderful. So the very last protocol that you're looking at right now is NTP. NTP is network time protocol. If I'm not wrong, that is network time protocol. As the name suggests, it's used to synchronize time synchronization, to synchronize time among all our network devices. So why do we need to synchronize time? That's what this slide is about. Time synchronization requirements. Why do we need to do that? So for network management. So if you want to analyze logs of when people came in, when people went out, if you want to debug messages, So you need time for reference. The time needs to be accurate. The time has to be accurate. If the time is not accurate, then this person can say I was sleeping with my wife at that point, and the wife will be the alibi, say yes, he was there, he was snoring. In fact, we had an issue in the morning because he overdid it that night. So you don't want the network admin to hack your system during the day. Then the log says he accessed it at 12 midnight. The wife will defend, and in a court of law, you lose that case. Okay, then charging system. So the clock of all devices must be consistent. It's important. Several systems working together on the same complicate event. What does that mean? Systems have to take the same clock for reference to ensure a proper sequence of implementation. Okay, so when systems are working together to accomplish a certain task, it's important that their clock are synchronized for them to be able to do proper sequencing of implementation of events. Then also when you are doing incremental backup between servers and clients, the clocks should be synchronized. Okay, so I don't want to go through all of them as we wind up. So the overview of NTP. NTP, just like the others, network time protocol is designed to synchronize the clocks of devices. So it uses a client server grouped by the group of distributed time servers. So it is based on IP and UDP. They are transmitted using UDP port number 123, 123, 123. If 123 is hard for you to remember, remember 123. NTP 123, UDP 123. So normally you'll have the NTP server, then your network devices like access points, router, switch, firewall, server, PC. They all can get time from the NTP server. So all of them are going to have the same time at any given point in time. So the structure of an NTP network, you might have the primary time server. The primary time server synchronizes its clock with the standard reference clock through a cable or radio. The standard reference clock normally uses radio or GPS, global positioning system, and therefore it's very accurate. It's very accurate. Then you can also have a Stratum 2 time server. This one synchronizes its clock with either the primary time, with this one here, or other Stratum 2 time servers within the network. So Stratum 2 time servers use NTP to send time information to the hosts in a local area network. So this one will get time from the primary or from their peers and send the time to LANs. Then we have Stratum. Stratum is a hierarchical standard for clock synchronization. So as you can see here, we have the primary time server, Stratum 1, then Stratum 2 time server here, Stratum 2, Stratum 3, another Stratum 2 time server. So that's sharing hierarchically that this one is the most trusted and most accurate. then now they can share with the others before it gets to the clients. That's what we call a stratum. Hierarchical standard for clock synchronization. It represents the precision of a clock. The value of a stratum ranges from 1 to 15. Smaller value indicates higher precision. So the value 1 indicates the highest clock precision, and the value 15 indicates the clock is not synchronized. Okay, so ladies and gentlemen, thank you for your patience. That is it. That is the end of this particular chapter. Please find time just now and discuss on these questions. Anyone with a question?